In the last video, we just gone through the fit functions and its returns, that is the history object. And we also learned how to use the training and validation set errors to judge the performance of a deep learning models. And in these lessons, we will talk about one very important argument in the fit functions, which is callback. Let's go ahead and get started. A callback is an object that you can provide in the fit functions that can perform actions at various stages of the training. That includes the startings or the ends of an epoch, or before or after a single batch, and so and so. And callback can be used to write TensorBoard logs after every batch of trainings to monitor your metrics, and also periodically save your models to the driver, and do early stopping, and also get a view on internal states and statistics of a model during the training. As a result, it's very important for us to use these callback arguments during the training. To execute a callback, a list of callback can be passed to the fit functions. While I'm talking about the arguments of the callback, you can actually provide a list to these callback arguments to the fit functions so that they can perform some functions that I mentioned here. The relevance methods of callbacks will then be called at each stage of the training, or you could consider that could be a epoch, or that could be based on the batch. Commonly used functions include the ModelCheckPoint, the TensorBoard, and early stopping, and we will go through it one by one. ModelCheckPoint is used in conjunction with the fit functions to save the models or weight at some interval, at a certain intervals that you would love it to save. A few options that these callbacks provide includes whether or not to just save the best performance functions, or whether to save the models at the end of every epoch, regardless of the performance. Definitions of the best that depends on which quantities that you are using to monitor, or whether it should be maximized or whether it should be minimized, and that we can define in this ModelCheckPoint. The frequency it should save us, that also depends on how you would love to save the models. Currently, the callback supports saving at the end of every epoch, or after a fixed number of training batch. And then also you can define whether only the rates are saved or the entire model is saved. So it depends on your choice. Once we got the models or the weights saved, we can lower it later to continue the training from the state saved. Therefore, ModelCheckPoints allow us to save the models or the weight at a certain interval, and in such a way that we can continue the trainings later on. Now let's take a look on the examples. Again, we're going to build this neural network that we have 3 inputs, 2 neurons at the first layer and 1 neuron at the output layers. And of course, we want to import the sequential model, the dense layer, and also NumPy. Let's run this cell and just provide the random input and also the output vector, and build a sequential model with 2 layers, with 2 neurons in the first layer and then 1 neuron at the output layer with the sigmoid functions. And we also compile the models with the atoms, MSE, and also MAE as the optimizer, loss, and also the metrics respectively. Let's run this out as well. And before we use the fit functions, we need to define the callbacks arguments. Commonly used argument includes the file path, the monitor, the safe bets only, and also the mode. If we are talking about the model checkpoint, these are 4 key importance arguments. The file path, of course, it has to be the path that you would like to be saved. It can contain a names formatting options, which will be filled the value of the epoch and also the keys in every logs. Say, for example, if the file path is weights.epoch, we can also pass it on a validation loss, and then we can, of course, put the file formats into it. And then the model checkpoints will be saved with the epoch numbers and also the validation loss in the file name. So that you just go back to your files and then you can understand you can have a peek on the epoch and also the validation loss. And of course, later on, if you want to get a trace on or get a track on how your validation loss is performing throughout the entire training, of course, you can go back to the history object, or you can just go to these files to take a look on the file names, so that you can understand how the validation loss is changing throughout the training. And of course, the directory should not be reused by any other callback to avoid conflicts. So in that case, it would be better for you to just to change the directory name. And for the monitor, it is the matrix names to monitor. Say, for example, if you would like to monitor the loss value, you can just provide an argument to the monitor. And then for the safe best option is that if it's set to be true, it only saved when the model is considered the best, and that is based on the validation loss that you are using. So the least validation loss will be saved in this case. And the latest best model according to the quantity monitors will not be overwritten if that is not the best performed model. And if the file path does not contain formatting options like the epoch or like these formatting options that we provided here, then the file path will be overwritten by each new better model. In that case, it will just keep saving the same models, but it will just overwrite the previous model because you're using the safe bet only options. Of course, if you would like to save every single models, then you can just change it to false. And then for the mode, it should be one of the auto, min, or max in this dictionary. Now, say for example, if safe bets only is set to be true, the decisions to overwrite the current save file is made. That is based on either the maximizations or the minimizations that depends on the monitored quantity. Now, say for example, for the accuracy or for the validations accuracy, that should be a maximizations. And then on the other hand, for validation loss or the loss, that should be a minimizations. In auto mode, it will just set to the maximum if the quantities monitors are the accuracies, or on the other hand, if that is for a loss functions, it will just change it for the minimizations automatically. Now let's take a look on the examples to see how we can set up the model checkpoint. First thing first, we need to import from the callback. We need to import the model checkpoint, and then we need to set up the file path. It has to be containing the a formatting options. In that case, the directory is my model, and then the formatting I just set it as the epoch with 2 decimal number. And then for the checkpoint, this is the model checkpoint. What I'm going to do is to provide some parameters and then assign it to the name that is the checkpoint callback here. The first argument is the file path, that is this file path. And then the monitor quantity is the metrics that I have, and so I provide the names to it. That is the lost. That is the MSE that I would like to measure, and in this case, I just put it loss. That it will represent this MSE. And then the mode that I'm using is a minimizations. It is because we want to minimize this mean squared error. And then finally, the final argument is that we want to save only the best function, only the best model. Now we are all set. Let's run this cell. Remember that a folder, or a directory, my models, must be created before the training, otherwise it will give you an error. Now we are ready to fit the model with the defined callback in a list. In that case, again, we are fitting the model with the input and output arguments, and then the epoch, we set it to 5, and then for the validation speed, just set it to 20% for the validations and 80% for training. And then for the callback functions, remember this is a list. So we need to put a square bracket for these objects. So we just put it equals callbacks equals to a square bracket with these callbacks that we just defined. Now, if I run this model for 5 epoch, and then there will be 5 folders saved in my model folder. Let me list out for your reference. Remember that we talked about how to save and load models in TensorFlow in previous video. There are 2 ways to save the model. One is the full models, and the other is the weight files only. In this example, we did not specify the format, so by default, it assumes to save the entire model. If you go to the folder, and if you click on the CO1, that is the number 1 file, and then you can see the x-axis, the variables, and also the saved models PB, which represents the entire model. And if you refer back to these information here, and these are the 5 folders that we just created. If I do not want to save the entire functions, what I should do is that I can just provide the file format that is the hdf5.hdf5 and put it over here, and then you can put it over the file path, and then you will get the weight saved in that case. And that's it for these lessons. In the next lessons, we'll continue with the fit functions and move on to the next callback argument, that is TensorPoint. See you in the next video. Bye-bye.